Hello and welcome to Identity Office Hours. I'm your host, Mike Schwartz, founder of Glue, and today is episode 46. Our guest today is Omri Gazit, co-founder and CEO of Authz. Welcome, Omri.
Thank you. Glad to be here.
And our co-host today is Nick Hunt, Chief Identity Officer and founder of authz Security. Welcome, Nick.
Thanks for having me, Mike.
So, Nick, maybe we could start with you, just in a round of quick introductions. Can you tell us about your role and authz Security?
Yeah, so my role is essentially founder, advisor, general identity architect. I got my start about 25 years ago in security. So my background is more of a developer, was doing pen testing, general audit and compliance. Went into consulting for a number of years. I worked for Oracle, worked a lot in healthcare. And for the last year or so, I've been working with a few customers as well as general best practices, documentation, writing, different stuff like that. So authz in general, we just provide advisory services, some software development.
Great. So Omri, you proposed this session today. Before we dive into the actual content, can you tell us a little bit, maybe before we go into Topaz and authz, just tell us, how did you get here?
Great. Yeah, I started my career as an engineer. I was a founding engineer at a startup that went public. I call that my rose-colored tour through startupdom. Spent 13 years at Microsoft after that, building basically all the .NET stuff over there. I was co-founder of .NET and then co-founder of Azure. I was a general manager responsible for a lot of the Azure services that focused on enterprise scenarios like identity and access. So access control service, Azure Active Directory, service bus, and a few other things. Left Microsoft in frustration at the fact that we kind of like stopped understanding developers in 2011 and spent the last 13, 14 years in open source. First on things like OpenStack and Cloud Foundry while I was running the cloud platform division at HP. And later on as a CPO and, in charge of product and engineering at Puppet. And over the last 3 or 4 years, started building authz, which is my third startup, and third time's the charm, as they say. We focus on authorization. Authorization being kind of an unsolved problem, whereas I would say that over the last 15 years, we've definitely solved the identity part of identity and access. The access part is still very much unsolved.
Right. So Topaz is a stateful PDP. What does that mean, stateful?
Well, let's first start, your audience is smart, so they know the difference between identity and access, or authentication and authorization. I don't have to explain that. That's usually where I start. But when you get to authorization, there have been, I would say the, kind of the term of art here is what we call the P*P architecture in Eve Mailer's words, or PDP being the policy decision point, PEP being the policy enforcement point, right? So,
by the way, let's not give that to Eve. As great as Eve is, wasn't it Martin Fowler who defined these architectural patterns back in the 80s or 90s?
He did. She just coined the term P*P.
Okay, P*P.
Yeah,
okay.
Exactly. To refer to all the P's, all the things like with 2 P's, like 3 acronyms with 2 P's and 1 letter in the middle.
I have a new P one that I even thought of recently, but okay, go on. So in the P*P architecture, where does this stateful come in? I guess let's drill down on that.
So traditionally, that architecture, kind of came XACML and NIST ABAC. And the idea was that the PDP is largely a stateless rules processor, right? So you write a program in a declarative language, and that program is able to execute on input that you send it. It can also talk to like an information point or a set of information points that contain the state that you want to execute an authorization decision on. And over the last, I would say, 5 years, we've now seen emerging an architecture where the PDP, the decision point, actually is stateful. Now, it started with OPA, where OPA said, you know what? We don't just want to write rules. We also want to put data in the form of a JSON file inside of the policy. But that was, I would say, a very elementary way of looking at things. It's very flat. It's not a very opinionated data structure. And it leads to, a lot of problems where, because policy changes fairly slowly and data changes very quickly, if you want to go build a new policy bundle every time a piece of data changes, that's just like a pretty bad architecture for it. We've now seen a new generation of PDPs that follow the Zanzibar model. And the Zanzibar model basically says, you know what? Authorization really is a data problem. And we need a way to, an opinionated way to express how the data is laid out. And specifically, we're going to say, we want to express relationships between subjects and objects and be able to lay those out in a graph and walk a graph, to be able to find out whether, Mike has access to, this recording. Mike is, the owner of the folder that this recording sits in. And so by navigating a set of relationships between Mike and a group, and the group being an owner of a folder, and the folder containing a document, Mike now has access to that document. And so when we say stateful PDP, we basically say the PDP actually contains not just a set of rules, but also a bunch of state that allows it to very quickly and efficiently figure out whether or not a user has access to an object.
Does that state mean that there's a database?
It always means that the data is stored somewhere. So if you refer to OPA as maybe the level 0 of a stateful PDP, that database is literally in memory, right? Like it's a JSON file that loads in memory. If the JSON file is too big to load in memory, the process fails, right? So that's the most degenerate case of a stateful PDP. But from there on, you go up and, if you look at Topaz, for example, it has an embedded database. So you can store a lot more data than fits in memory. And it has a demand load architecture. It's basically an ISAM where, you're looking up things by key. It has a very efficient way of looking things up by key. And you load up things like the subject, the object, and all the paths between them. So that becomes a very efficient architecture. And Topaz can make an authorization decision, even though it's stateless, in typically under a millisecond. And then you go to the next level of that. If you want to put a relational database behind the stateful PDP, we have in Asserto, we have commercial solutions that do that. SpiceDB does that as well. OpenFGA does that as well. Those are other implementations of readback systems. So most readback systems that we know about have some database, typically a Postgres, sitting behind.
Right. Well, let's take a step back. And Nick, Omri, in your article, you mentioned that broken access control is the #1 OWASP web application security issue, which I think we've been staring at for some time. And I wanted to pivot to you, Nick, and ask, why is that? And does leadership have any ownership of that? And could it be because security can almost be an afterthought sometimes? I'm just wondering if you could sort of put this authorization question in some perspective of the enterprise customers.
The broken access control from an OS perspective, maybe take a little bit different take on it. And the reason I think this is still, top 5, top 1 from a OS top 10 is identity and authentication are still very hard, right? Developers, may not understand a lot of these concepts or have ideas of how, they've done it in the past and have their own authorization model that doesn't scale very well. To Omri's comment, right? If he can do sub-second or millisecond authorization decisions, someone building this in kind of a static, attribute and or, inherited model in their app, there are going to be gaps. That's kind of one aspect of it, talking to a lot of my customers. The other aspect of it is there's been no consistency. There hasn't been a standard to define these types of models or ask the right questions. So we've got 25, 30 years of history of different access control mechanisms that now that the standards and the technology is actually coming out to start enforcing these things, we got to carry a lot of this stuff forward. So I think it's really training in its standards.
Yeah, I couldn't agree more. Like, I think I've given a talk at Global AppSec, OWASP Global AppSec, on fixing broken access control. You ask, people in the room, how many of you are engineers? There's like 3%, right? So we're really talking about two completely different constituencies. I gave the same talk at Vancouver at AppSec Days, same thing, right? Like, most of the people in the room are breakers, or kind of managers of security programs, and they have a set of tools. They're mostly tools that are either doing static or dynamic, kind of just analysis against these these systems, like using Zap or things like that. And all they know is how to find these vulnerabilities, and they're really powerless to do anything when it comes to the software delivery lifecycle. If you look at what happened to authentication 15 years ago, I remember, like, routinely you would hear about, like, some website got broken into because they didn't use bcrypt correctly to encrypt passwords. So all this, there's dictionary attacks against these things. Like, it was just elementary stuff that kind of broke all the time. And it wasn't until we had a standards-based way of authenticating, and then vendors like authz and Okta and all the rest, and Azure Active Directory, to like go build a standards-based authentication solution, that developers got out of the business of doing it, because developers really didn't want to build these authentication systems. They didn't really add any value to the application. They didn't make their beer taste any better, right? And so, like, they were all too happy to move to something that was easy ergonomically for a developer to use and adopt, and on through the same cycle. And to your point, Nick, that's exactly why we started the authz working group in the OpenID Foundation, is to try to bring about that OpenID Connect moment for the authorization space. Because right now we have 15 plus vendors building authorization systems. None of them are compatible. And so, we got to get to the point where we have that convergence so that developers don't have to go build access control so poorly. If you talk to OWASP, they'll say 94% of the applications they test exhibit some form of broken access control. So it's clearly a huge problem.
Maybe I could show this diagram, because I'm wondering, the title of the of the episode today was about multi-layer authz. And what I wonder is, how deep does that actually go? I'm going to full screen this in case any of our guests or audience is watching on their phones. But when you think about it, the policy decision point, when I think of multi-layer authz, I think about potentially putting the policy decision point in various places around the network, maybe in the application itself, in the API gateway, in the OpenID provider, in the backend API, maybe even embedding it in the CRM, the cloud infrastructure, like Amazon. We did an episode a couple of episodes back with Alex Sierra talking about Amazon's identity and access management controls, which are quite complicated, or even who has access in my company to post to LinkedIn or YouTube. So authorization is this sort of problem, or not problem, but challenge that we see across so many applications, that what I'm wondering is, and Omri, I'd like to direct this question at you, is how deep does this go? And what do you mean exactly when you say authz multi-layer? What layers are we talking about exactly?
Yeah, it's a great question. And I think it starts with zero trust, right? Like, as much as all of us hate that term because it's so overused and, it seems to be devoid of meaning. The whole point is that you're moving from a parameter-based approach to security to assume nothing, don't trust anything. And you're moving the burden of securing applications from the environment to the application itself. And you could do that in a lot of different places, right? So if you take, for example, the access proxy, that works at the network level to ensure that a user, is logged in or is kind of as they try to access an application, they do it from an approved device and with an identity that is known to the system. That's one place, that's not even on the diagram, but that's something that people have been doing for 5 or 10 years now. Another place is the identity provider. So today, if you look at how authorization is done, a lot of applications just say, you know what, the identity provider, as it's minting an access token, is going to try to figure out what roles or permissions a user has and stick those as scopes in an access token and call it a day. Now, you can get me like talking for a whole day about why that's an inherently insecure and not a fine-grained access control type of practice, but it's still a practice that people do today. And so if you had a standard component, a PDP, that kind of identity provider can go talk, you need to either kind of make a fine-grained decision before I stick a scope in an access token, or I can even decide what scopes I need to put in an access token. That PDP can help make that decision and can be a standard architectural component. At the next level, before a request is dispatched to a back end, you have an API gateway typically. An API gateway that's their job in life. Their job in life is to, kind of have request filters that execute on requests. Sometimes those are, things like, kind of security oriented. Sometimes, you're trying to, kind of put API rate limits and things like that. But authorization is a perfect thing to do at the API gateway. In fact, there's a lot of prior art there with integrations between Envoy and Istio and Kong and things like OPA. That's another place where, standard, that's a standard place where you could put authorization in the critical path and make an authorization to make a call to a PDP before you dispatch.
And a history of reverse proxies too. Actually, Nick remembers Oracle Access Manager days, but one of the practices was put a proxy in front of it, a web proxy in front of your web application, and enforce security there. So it's not just that it's something that people discovered. We've actually been doing that for decades.
And then the last place I'd say, the most obvious place, is the application itself. This is what we call broken access control. This is the place where applications typically get it wrong. And so again, if you have a standard architectural pattern where right before granting or denying access to a protected resource, an application can call out to a PDP and say, hey, this is the subject, this is the permission, this is the object, does the user have permission or not? That's another, obvious place. And you put it as the kind of mobile application, but you could imagine that could be the web front end as well. A web front end typically wants to go find out what what actions a user can take and what objects they can see before putting them on a screen, so to speak. So you don't want to have a user experience where you see something like, for example, you see a purchase order and you say, I want to approve it, and then you get an access denied from the back end. You don't even want to display that action, the approve action, if the user doesn't have access to that. So that's another place where the front end can actually get some hints about how to lay out their UI so that they don't end up with a poor user experience. So all of those things, I think, are represented in your diagram. Yet another one is Kubernetes admission control. Yet another one is kind of, I would say, microservice to microservice authorization, where, for example, you never want
workload as whimsy, exactly. Or workload, as it's called today.
That's right. You never want a, like in Europe, you don't want by accident microservice in Europe to call a microservice in kind of North America, for example, for data locality reasons. Or perhaps you don't want, a production service ever to go talk to a service that's in the engineering environment. Those are classic, kind of microservice to microservice authorization types of scenarios. So for all of those scenarios, you can have a standard component, the PDP, that makes those decisions.
Nick, maybe I can pivot to you and ask. So there's a hornet's nest of places where ideally we'd like authorization. That's sort of what I'm hearing. Nick, where do you see in the real world, like where are we today, and where do you think we need to move to for authorization?
I 100% agree with Omri here, right? I think the traditional ideas of authorization are at the authentication source, right? So on login, are they a member of a group? And try to shove a bunch of stuff in a token, right? And basically pass that to backend applications to start making decisions. One, that gets kind of stale, based on changes, and two, it doesn't add any context to the actual authorization package, right? So from where we're going, kind of what we need to do, the big question to me is asking the question at the different PDPs, right? And then providing a response in a format that they can consume. So if we use the general token example, right? If I know there are 5 hops, you got the web gateway, you got an API gateway, you've got a front end app, and you're trying to put all that data in a single token, and each one is trying to basically parse that data for their purposes, it's just going to take forever to generate all that. And how often do you go back and kind of renew that data in the token, right? So keep it minimal up front, and then all those hops in between basically slice and dice and provide the data they need in the format they need. But the challenge here that I run into is getting those devices, from a PDP or PEP to actually ask the question, right? They're relying on existing ways of doing it, and asking the right question when they need it is functionally a little bit different. So, it's getting off of kind of what we have available and starting to leverage some of these things, but also from a engineering architect perspective, giving them data, in a format they can consume and use it.
Yeah, and maybe I'll just jump in and defend the old token here. I would argue that maybe the token is the input to the policy. So when we are saying, are we trying to load too much into the token, the minting of the token for authorization? In my opinion, the token is just one piece of the puzzle. So if I'm an application, I have a token, but I also have a context because I know what's the action and what's the resource. I also know IP address and other contextual data. So isn't the token really just, it's a really useful piece of data because it tells us the details of an authentication event. It also tells us that a certain piece of software was authenticated. So from a trust perspective, the token is really useful, but maybe the problem isn't that tokens aren't good for authorization, but that tokens were never meant for authorization. So you're projecting your dreams onto this token and trying to get it to do something that it was never meant to do.
That's exactly right. That's exactly right. Vittorio Bertocci, the late great Vittorio, wrote a fantastic blog post. I think it was 2015. He's prescient on a lot of issues, and it was called, basically like stop abusing OAuth scopes as permissions. He explained that the OAuth 2 protocol was initially designed for delegated authorization, user-centric delegated authorization. And, scopes were starting to get abused as permissions. And I kind of wrote a blog post that kind of built on that and explained why this kind of abusive practice just doesn't make any sense. Like let's take Google Docs as an example. Why doesn't Google like the set of documents that you can access as scopes in an OAuth token? The answer is obvious, right? Like there's really 3 things. One is you're logging in. When you're logging into, Google Drive, does Google really try to compute all of the documents that you have access to? Like could be hundreds, could be thousands. First of all, too many to actually stick in an HTTP header that has, kind of like specific lengths. And like as Nick said, by definition, as soon as that token is minted, it's out of date, right? Because I could have just, revoked access to Nick's document, after he logged in. And so the lifetime of that token is kind of meaningless, right? Like for a dynamic system like Google Docs, you need to make a real-time decision using, kind of the data that you have at the time. Now, back to what you said, Mike, I think the JOT, the access token, is an excellent source of input information for making a decision. So some of that information, for example, like what roles the user has or what groups the user belongs to, you could maybe make the argument that that could have, like you could have stale information and that could work, especially if you have a system that refreshes groups every day. Like if you had a batch job that basically says, I'm going to go refresh, the set of groups that people belong to on a 24-hour basis, then that's the, staleness interval that you're okay with in terms of, minting group membership in an access token. If your system's more dynamic, then you don't even want that. Like, so for Google Docs, for example, if I remove Mike from the engineering group, Mike automatically, access to any documents that are in, kind of like that are owned or that are viewable by the engineering group. So I think you have to be very careful about what data you can rely on in terms of, kind of using in an authorization decision, data that you find in an access token. You have to first ask yourself the question, is that data more volatile than the expiration, the lifetime of that access token? If it's more volatile, then don't rely on putting that data in an access token.
You said in your article that you wanted to move access control sort of into the RP, the relying party. But today, a lot of the relying parties are actually built into the browser. So we have browser-based applications like React and Vue, et cetera, and mobile applications. And the use case I wanted to throw at you was, let's say I have one of these. So I have a FIDO credential that's where the private key is bound to the hardware. And I have a policy that says in order to do this thing, I need to basically have a private key that's not, synced. So for that type of policy, we really need the policy to be the best place for that policy would be in the browser-based app or in the mobile app. Why do I have to make a query upstream that, oh, here's the authentication I have? Well, that's not good enough. Do this type of authentication. So it seems to me like there's a certain subset of policies that really, even though you can't rely on maybe everything, that's why we need multi-layer, but still there's a subset of policies that really need to exist in the application itself, embedded in the application. And what are your thoughts, Omri, about embedding a PDP in the front end? And where does that is that sort of part of the solution that you're envisioning?
Yeah, I mean, in the end, like I think the pattern itself of externalizing authorization is a powerful pattern. It gives you, like in computer science, you solve every problem by putting in one more layer of indirection, right? And the not to be facetious, I think externalizing authentication has really served us well over the last 15 years in the IAM space. I think externalizing authorization can serve us really well as well. There are some problems where, like I think the abstraction kind of runs out of room. I would venture to say that even for scenarios, where like you're talking about, something that feels like an embedded component, you could still argue for an externalized authorization architecture. Like take OPA, for example. You can take OPA policies, compile them into WASM, and run them in the browser. So that is, that's something that you can do today, and that's a very efficient architecture for externalizing authorization, yet running it very efficiently. You can take engines like the OPA engine, for example, and since it's a Golang package, you can run it embedded in your application. There are other externalized authorization systems that do that are written in Rust.
Yeah, WASM. For example, Cerbos. or Cedarling that Glue is developing
Yeah,
also
Cedar's
runs
a great
that.
example of a Rust-based engine that you can basically compile into your application. And so, I would say the pattern, the externalized authorization pattern, is a powerful pattern, and it extends to a surprising number of use cases, down to even embedded use cases. But the appropriate pattern for every single possible scenario. We've seen people that try to use Topaz, kind of in like kind of electronic, kind of like access, like physical access scenarios. So we think that kind of if you have a binary like a Linux or Windows binary that can run everywhere, there's a lot that you can do with it. But that doesn't mean that it's the right solution for every single scenario.
Yeah. So Nick, you go ahead. Yeah, please.
Well, I was going to kind of add on here a little bit, right? From an external authorization, Omri's example of external authentication authorization. I think there's kind of an underpinning here that we haven't really asked yet. But, what does it mean to authorize? I think when I talk to a lot of people, they assume authorization is a yes or no type of question, right? But stateful, authorization platforms can give you context around that authorization. So your FIDO example, your network location, type of device you're in, all these types of things can all feed into a policy-based response that says, yes, you can do X, Y, and Z because of you have FIDO, you have other things, right? That your application can consume and start responding appropriately. A binary response of can you do something or not versus giving context around it is a much better experience, right? It's not a you can't do something because you don't have a FIDO key. It's, well, you can't see this because you don't have a FIDO key, and an app can respond appropriately.
Yeah, for sure. And those are definitely scenarios that we've talked about in the the authz working group. Rohit had a comment here I couldn't help but read and I think the whole point of defense in depth is to be able to provide authorization in a lot of different places. And so yes, it's true that, like, let's say I have a front end, like a React front end that is trying to do quote authorization. I may use a PDP to lay out UI hints, for example, to make sure that I don't display actions that a user doesn't have access to. But ultimately, I'm going to rely on the backend component to doing the authorization correctly. Like the idea of having the front end, kind of be the thing that determines access is obviously not correct architecturally. Authorization has to be done by the component that is guarding the data. But that doesn't mean that the front end doesn't have any role to play in authorization.
Can improve the user experience, So
exactly.
I think that's the thing is like, yeah, we can't rely on the authorization engines, enforcement entirely in the front end. We don't trust the browser, but it doesn't mean that we can't maybe build a better user experience if the React app is aware of the policies.
That's exactly right. And in fact, we have a pattern in Topaz that is called decision tree, where the React front end, we have a React SDK that will make a call to the kind of back end, and the back end will return all of the possible actions that a user can perform on a resource. Search is another great example where like the back end may want to go limit the number of things that the front end is able to, like that get transmitted back to the front end. You don't want to do the filtering on the front end. You want to do the filtering in the back end. And so like PDPs have a broader role to play. They can provide UI hints for front ends. They can also assist in answering questions like, not just does Mike have read permission on this document, answer the question, what documents does Mike have read permission on? Like, let's go display those in a list as opposed to display all the documents. And then when Mike tries to open the document, called top secret, Mike doesn't have permission for that. And so Mike gets rejected. I think those are, really strong UI use cases where the authorization system is doing some extra heavy lifting for you, even though the, kind of authorization is not happening on the front end.
And thanks for the question, Rohit, former Identirati. Forget what episode. So Nick, I want to actually ask, what happens when all this sounds great, but what happens when authorization fails? And so if we're going to have this multi-layer defense, what's the impact on, let's say, detecting and preventing an attack, revoking access when an attack happens, and also showing evidence of compliance for attacks? Like, any thoughts on what's the sort of audit or CISO view of this?
So I'm going to start on kind of the last part of your question first, which is the forensic side of it, like knowing what people accessed, right, based on an authorization decision, regardless of the decision kind of upstream, asking the question and saying, using Omri's example of what read document or what documents does Nick have access to read access, right? Authorization said X. The logging showed they essentially saw A for some reason, right? You can actually start tying some of this data together to say, like, hey, they accessed A because of a broken enforcement somewhere in the chain, so to speak, right? You can actually start tying that data together from a forensics perspective to say, hey, this is a possible breach or a possible disclosure, everything else. I think a lot of things today are very reactive, from like, hey, I think someone accessed my data and you got to go backtrack, versus like, hey, I know Nick shouldn't be accessing this document, but he is based on an authorization policy.
Mad
This is
queries
more of
and Splunk ensue, basically.
we're not going to bring up that, but yeah, it's more having more metadata, kind of the forensic side of it, being able to do this, right? The kind of moving upstream from a security auditor, compliance, everything else perspective, it gets kind of challenging. The tech side of it's easier because we can track it and we can kind of show. But as you start moving up the stream, the different concepts of what necessitates a disclosure or an authorization failure gets harder and harder, right? I think we're very centered or centric around entitlement driven or role-based access control. Defining an audit control or a report around a policy and essentially attesting to that upstream, that it's actually acting like it should, or if there is a policy violation for some reason or a gap, it gets harder and harder. So that's honestly, it's a lot of training. It's a lot of periodic testing. And yeah, it's kind of a slow process as you move up a little bit from the back end PDP, PEP, P star P. I'm going to start using that, Omri.
Thanks, Eve. Yeah.
I've been too many calls where it's like, well, it's the PEP, PIP, PDP. But yeah, from a forensic kind of moving upstream, I think it adds a lot to it. It gives a lot more visibility. You get a bit more proactive. The challenge is going to be attesting to that as we start rewriting audit controls and attestations and everything else.
Yeah, I mean, Omri, one of my thoughts also is that the business value for the technical value is great, but it seems to me like if your enterprise needs to justify this expense,
Yep.
a lot of the business value might be tied more towards the audit compliance, forensic analysis, and revocation of access, real-time revocation of access.
Exactly.
What are your thoughts on? I mean, how does that need to be architected, and how are we doing today?
Yeah. So first, I'll say, a lot of people ask me, okay, you've been doing this for involved, with SAML and XACML. How come, we now have interoperable authentication and we're still wandering in the desert of authorization? And I think one of the answers I give is that we've had two types of solutions on the, like there are developer-centric solutions that don't really kind of spend any time thinking about all these other personas, central IT and auditors and so on, and compliance and forensics. And then there are, solutions that get sold into central IT that, are largely shelfware because developers really, have a really hard time adopting them. Example is one of those things, where it's, a bunch of angle brackets, and it was really hard to, for developers to kind of get their head around it, and they never really did, adopt it. And so you really need solutions that are able to cater to kind of a broad audience, stakeholders, both the folks that are in, kind of engineering, so dev and DevOps, as well as folks in IT. So, whether it's security, the AppSec teams, the IT administrators, compliance, and forensics. So I totally agree with Nick when it comes to that. I think a lot of the selling points of, this, type of software into enterprises is, how does it allow me, like, how does it rendezvous with my existing processes? To Nick's point, a lot of IT is used to things like role recertification and things like that. And in some ways, dynamic externalized authorization means that you can start engaging in practices like zero standing privileges or principle of least privilege, which you don't really need to do those kind of standing roles anymore. And so, like, it takes a little bit of culture that no, this product in this RFP, I don't need to ask for whether this product makes it easy for me to audit roles, because we're really talking about things that are not standing entitlements. We're talking about assigning dynamic permissions that are easily, revoked by, the people that granted them. I do think that the decision log data stream that authorization systems produce, that PDPs produce, is a goldmine. So like with forensics today, like most pieces of software don't really have that decision log stream. So people who are trying to figure out how bad a breach is all they have is kind of the login trail. Okay, so Mike was able to log into this system from this IP address that we didn't recognize.
As I said, mad Splunk queries ensue.
Exactly, that's right. Mad ensue in a set of data that just isn't fine-grained enough. When you have a log of every decision that each application has made, including the subject, including the resource, the action that you were trying to execute, what the state of the system was at the time, you have a much richer picture of what actually happened, and what data may have been exfiltrated, what data may have been changed, and so on. And so all of that data, I mean, the best answer that we have today is you pour it into your SIEM system along with other data, but at least you now have a much richer set of data to have your mad Splunk queries get executed against, right? It's not just login data, it's also kind of a full trail of every decision that the application made. So I think that is a huge carrot for IT organizations to go authorization architecture throughout, because it gives them now much richer tools for being able to do those things.
So we're bumping up against the top of the live stream. I go to last thoughts. Nick, we'll start with you. Any last thoughts?
Yeah, I mean, like the title says, authz, yes, please. As much as we can integrate it into different hops, we need to start looking at it, right? And move beyond kind of, static dynamic ways of defining authorization. My big recommendation or conversation with people is just make sure you're asking the right question and providing context at those hops so they can make informed decisions, right? But yeah, that would be my kind of closing thought on this.
Omri, last thoughts?
Mine would be, the externalized authorization pattern is what's coming next. So if you were excited about single sign-on using kind of an SSO system back 10 years ago, and you said, okay, all my SaaS and all my internal applications are now going to talk to the same identity provider, you should think about your authorization system, your PDP, in the same way. You'll want all your applications to use an externalized authorization architecture. We are partial to Topaz. Topaz is an open source project that we sponsor. It combines the best of OPA and the Zanzibar model, but there are plenty of others. So the only unacceptable path forward, I would say, is for applications to continue to try to go build authorization by themselves, because it's surprisingly hard. It's easy to get wrong. 94% of the applications that OWASP tests get it wrong. And so like I would say rely on tools that built for that. And the last thought is help is on the way from a standards perspective. So we have the authz working group inside of the OpenID Foundation that's trying to standardize that so that you can basically use a single protocol for being able to talk to now 13 PDPs and counting. So that's, if you're not familiar with the externalized authorization architecture, now's the time to do some research on it.
I think we'll get to that at another point. And just to reiterate what you said a little bit there is, if you implement your own security, not only are you 94% likely to get it wrong, but you're almost 95% likely not to write a proper log for every authorization decision. So we won't have the evidence that we need or the ability to do forensic analysis. So, okay, well, thank you, Gus. It was a great conversation. We only go about an inch deep in 45 minutes, but it was fun. Next week, we'll be going back to the AI topic. Lasse Andresen, former founder of ForgeRock, founder of IndyKite now, is going to join us next week. That should be great. Or I'm sorry, this week on Thursday, next Thursday. So we'll see you then. Thanks for the questions, and we'll see you next time. Thanks, everyone.